Hello again, everyone. Um, Welcome back to our series of maths lessons. We try to keep it simple here by explaining mathematics simply. A lot of people have misconceptions about what mathematics is all about. They just assume that it's a very difficult subject. But truth be told, mathematics is one of the easiest subjects that you can learn if you just stay focused and if you learn from someone who breaks it down for you in this very simple manner, which is what we intend to do in this series. Um, so we started from scratch. We started building up mathematics right from um, where we started learning in primary school, in our early years in primary school and even nursery school. Mathematics is all about numbers. It starts with learning numbers, understanding numbers, being able to write numbers in words, being able to write numbers in digits, using digits, which is what we have been doing over the past 5 lessons. In the past 5 lessons, we have learned about place value, the place value and the value of the digits. That's what we've been learning over the past 5 lessons. We've learned how to write number in digits after you've given it in words. But we started off by um, learning how to write numbers in words when they're written in digits. And then we moved on to learning how to write numbers in digits when they're written in words. And we found out that that's much easier if we have mastered how to learn how to write numbers given the digits and then writing it in words. In the last lesson, I reviewed the last lesson and I found out that we did not talk about how to write 5-digit numbers in words. But then I'm sure those of us who have been following the lessons will know how to do that, even though we skipped that. We learned how to write a 1-digit number in words. We expected everybody to know how to write a 1-digit number in words. We moved on to writing a 2-digit number in words. Sorry, in the last lesson, we did the opposite, the reverse. We talked about if a 1-digit number is written in words, we'll be able to write it in digits. We talked about if a 2-digit number is written in words, we'll be able to write it in digits. We moved on to um, writing 3-digit numbers in words, and then we should be able to know how to write it in digits. Moved on to 4-digit number, and then we moved on to 6-digit number. I discovered, as I said already, that we missed out on 5-digit number, but then it's still the same process. So this is the last example we did in the previous lesson. We moved on to 7-digit numbers, and we stopped there. But obviously, we can even carry on. The principles are the same. So what we are going to do now is to review how to write 5-digit numbers. I'm going to write a few 5-digit numbers in words, and then we going to write it in convert it to digits, just to complete what we missed out yesterday. Which, as I said, I'm sure you can even handle if you went through yesterday's lesson and you've been following all our lessons. But just for the sake of completeness, let's just review what we did yesterday by looking at 5-digit numbers. Okay, so I'm going to write a 5-digit number in words, and I'm going to also say it in words as I'm writing it, and then we'll write it as digits. So 25,000, comma 264. First thing says 25,000. So let's write 25,000. Remember, 1,000 has 3 zeros. So 25,264. So let's write 264 over here, and then we can add those two numbers together. 2 plus nothing is 2, 5 plus nothing is 5, 2 plus 0 is 2, 6 plus 0 is 6, 4 plus 0 is 4. 25,000, remember 1,000 has 3 zeros, 25,264. Let's do one more example. If I want to write 98,000, 98,000, comma 365. We want to write 98,365 in words. So we can write 98,000. Remember, 1,000 has 3 zeros, and 98,365. So add 365. 365 days in a year. It's just occurring to me. Maybe that's why I chose that. Anyway, you now add those two numbers together. 0 plus 5 is 5. 0 plus 6 is 6. 0 plus 3 is 3. 8 plus nothing is 8. 9 plus nothing is 9. And so that's 98,365. Okay, so that's just a summary of what we did in the last lesson, writing a number in digits, given that that number was given to us in words. So we are moving on now with our mathematics. Remember, we're just imagining that we're back in primary school and we're just recollecting the things we started doing, how we started off in mathematics. The main reason for this series is so that this series is accessible to everybody. It's accessible to children, it's accessible to adults who did not have the opportunity to go to primary school, or even if they went to primary school, their education was interrupted for one reason or the other. This series will help them to be able to understand what mathematics is all about, up to secondary school mathematics. And in fact, the series could even carry on up to A-level mathematics. So the whole point is to break down mathematics and debunk the myth that mathematics is a difficult subject, because we try to explain it as simply as possible, and we build everything up step by step. And that's why we call our series Mathematics Explained Simply. That's the title of our series. We try to explain it simply and not try to make it too complicated. We break things down. So let's talk about addition, and let's cast our minds back. I'm going to cast my mind back when I was in primary school. I remember when I was in primary school, I vaguely remember when I was in primary school, the first few lessons I had in mathematics was all about counting, counting from 1 to 10 and then counting from 1 to 20. I remember we given objects to count, maybe lollipop sticks or wooden blocks and stuff like that. So from counting, we now went on to how to add numbers together. Started off by adding two numbers together and then moved on to adding more than two numbers together. And I remember we used lollipop sticks. So we could be told to add three lollipop sticks to five lollipop sticks. But then again, before we even go into all that, let's talk about different ways of saying addition. Because in examination questions, some questions, because it, basically in examination questions, some questions will be real life questions, real life problems. And when you read through the problem, you now begin to tell yourself, oh, this is a question on addition. I need to add this to that. Or, oh, I need to multiply this. I need to multiply these numbers together. We'll talk about multiplication in future lessons. So, mathematics exams at some point will not just be, oh, add this number to that number. It will get to a point where real life examples will begin to show up. For instance, oh, uh, you have five apples, and then somebody comes and gives you 12 extra apples. How many apples do you have altogether? Questions like that, real life scenarios. And also, we're going to do takeaway in a few lessons' time. We'll talk about takeaway. So you can have real life scenarios where, oh, you go to a shop, Paul goes to a shop, Jane goes to a shop, Deji goes to a shop, and Deji has £1 in his pocket. Paul has £1 in her pocket. Jane has £1 in her pocket. Goes to a shop and buys a packet of sweets costing 68 pence. How much change will Deji receive? How much change will Jane receive? Those are real life questions where you have to use subtraction. Take away. Take away means the same as subtraction. You have to take away 68 pence from £1. And also need to know that you have 100 pennies in a pound. So basically, you're going to be doing 100 pennies, take away 68 pennies, or 100 pence, take away 68 pence. So these are the kind of ways mathematics helps us in real life. Some people go to a shop, buy a bag of sweets, give the shopkeeper some money, the shopkeeper gives them change. They don't bother to check the change. They just take whatever they are given. But if you're good with your subtraction and you're good with your mental maths, you should be able to check if the change given to you is correct. But anyway, we're not talking about subtraction today, we're talking about addition. And we're taking it right back to primary school. And I was trying to say that there are different ways we can um, talk, we can mention, there are different words we can use for addition. So let's first of all put down different words that we can use for addition. So let's put addition first of all. Addition, it means the same as sum, the sum of 5 and 3, the sum of 8, 10, and 9. It's the same as addition. So let's put the word sum, or if you like, sum of. So addition, that means at times you can say add. You can say add these numbers together. Find the sum of these numbers. Or you could be asked, what is the total of 5, 8, and 10? What is the total of 100 and 400? That's addition. So that's another word we need to watch out for. Total. Total of. So these are words that could come up in addition. If I think of another word that could come up during this lesson or in a future lesson, a synonym for addition. Synonym means the same as. So if I can think of any other words in the future lessons or in this lesson, then I'll add it later. So going back to primary school now, I remember when I was being taught addition, as I said, I could be given lollipop sticks, wooden blocks, and all of that. So I could be told, what is the sum of 3 and 5? So 3 plus 5. Plus is the addition symbol. Equals means the answer is. So the equals means the answer is. So 3 plus 5 equals whatever. Whatever you get is the answer to the question. Plus means addition. Plus means the sum of. Plus sign here means the total of. That's the equal sign. It means the answer is. So when I was in primary school, when I started addition, 3 plus 5, my teacher gives me a bunch of lollipop sticks. Says, take 3 lollipop sticks from there. And I take 3 lollipop sticks from there. Take 5 lollipop sticks from the same bunch of lollipop sticks. I count out 5. I take the 5 lollipop sticks out. Then she says, count all of them together. And then I count all of them together and I get 8. At some point, my teacher did not give us lollipop sticks. Said now, instead of using lollipop sticks, you draw lines to represent the lollipop sticks. Or if you want to draw circles, whatever you want to draw. But mainly we use lines because you can draw lines quickly. And so we didn't use lollipop sticks anymore. We use lines. So three lines, 1, 2, 3. Remember, we have already been taught how to count by this time. We count 1, 2, 3 sticks, and then we count 5 sticks. 1, 2, 3, 4, 5. And then we count all of them together. Then we do 1, 2, 3, 4, 5, 6, 7, 8. And we get 8. And then our teacher moved us one level further. Our teacher said, you know what? Why will you waste your time putting 3 strokes to represent 3? Why don't you just count from 3? Count from 3. So instead of wasting time putting 3 strokes for 3, just put the 5 strokes and start counting from 3. So you go 3, 4, 5, 6, 7, 8. Saves a lot of time. And then again, our teacher told us, let's even save more time. Why don't you count from 5? Why don't you count from 5 this time? And then this time put 3 strokes. 1, 2, 3 to represent 3. And count on from 5. 5, 6, 7, 8. You still get 8, but you get to your answer faster. Why? Because 5 is bigger than 3. And we began to see that, oh, we could clearly see with this kind of explanation that 3 plus 5 will give you exactly the same answer as 5 plus 3. It does not matter which one you start from. 3 plus 5 is the same as 5 plus 3. When we do multiplication, you will discover the same rule works here. In future lessons, we'll talk about multiplication. You will discover that with multiplication, 3 times 5, for instance, is exactly the same as 5 times 3. When we come to subtraction, taking away, you will discover that this rule does not work. For instance, 5 apples, or let's say 6 apples, divided by 3 people. You have 6 apples, you want to divide it equally between 3 people, is not the same answer as having 3 apples and you want to divide it by 6 people. Also, takeaway. It doesn't work for takeaway. If I have 5 apples and I take away 3 apples, it's not going to give me the same answer as if I have 3 apples and I take away 5 apples. Because I have 3 apples. How can I take away 5 apples when I don't even have up to 5? I have 3. So this rule that I've shown you here works for addition and multiplication. So just to repeat, 3 plus 5 will be exactly the same as 5 plus 3. Another example, 8 plus 10 is exactly the same thing as 10 plus 8. It does not matter which order you write it in. In maths, we call this the commutative law. You don't need to remember what the law is, but we call it the commutative law of addition, commutative law of multiplication, or we say addition is commutative. We say multiplication is commutative. And that simply means what I've shown you. It means it does not matter which order in which you add the numbers, you will get the same answer. Okay, so yeah, these are the things that I learned when I was in primary school, when I was a young person in primary school, just starting off school, just starting off maths. Some of you might be wondering, oh, why am I overemphasizing something so simple and all of that? But I can tell you that if you know the principles, the basics of the things we do in mathematics, when we get to the harder stuff, it will make more sense than it would have made if you don't try to understand the simpler stuff. Okay, so back to the addition itself. So I've shown you how I was taught the addition. Just to reiterate, started with lollipop sticks. From lollipop sticks, we moved on to putting lines for the two numbers. After some time, the teacher moved us up another level and said, look, don't let's waste our time putting all the lines for the numbers. Put the lines for the smaller number and start counting from the bigger number so we can get to the answer quicker, as I've just shown you over here. 5, you start from 5, you start counting from 5, you put your 3 lines for 3, so you go 5, 6, 7, 8. Saves us the time putting the lines for 5. So basically, that's how we introduce addition. This is addition of one-digit numbers. Obviously, in life, we don't just limit ourselves to one-digit numbers. Like I gave example of going to the shop, you have £1 and all of that. £1 is 100 pennies, 100 pence. That's a three-digit number. So we have to move our addition up one more step or more steps where we're going to be adding big numbers, like the big numbers we've been talking about in previous lessons. We've been talking about numbers up to the millions. We've been talking about numbers in the thousands. Obviously, you're not going to start putting lines or lollipop sticks. You're not going to, if you want to add maybe 2035 plus 8064, you're not going to start counting out to over 2000 lollipop sticks, over 8000 lollipop sticks, or putting over 2,000 lines, putting over 8,000 lines and start counting all of them. You're going to be there all day. And the beauty of mathematics is you can still add big numbers together quickly using methods. There are methods people have come up with in mathematics that give you the answer quickly, not just in adding big numbers. A lot of things can be done quickly in mathematics. And a lot of things can be done quickly. A lot of complicated things can even be done using the computer. So mathematics is involved in building the computer, and the computer can add numbers with so many digits with a snap of a finger. So the main thing we're going to learn now is how to use the column method of addition to add bigger numbers. So let's start off with using the column method of addition. We start simple. We want to add a two-digit number to a one-digit number. Now, I want to emphasize there are other ways, other methods of addition apart from the column method of addition. Other methods, you can use the number line and stuff like that. But I don't want to go into all those other methods of addition. Let's just stick to this column method of addition. Any other method will develop naturally with yourself, kind of mental maths methods. That's left for you to develop on your own. As we learn stuff in mathematics, you will discover that you will begin to come up with fast ways of doing things. But what I want to concentrate on now is the column method of addition because it will work, it will always work. Other methods could change. The method could change depending on when if the number gets bigger or whatever, or if you are using the number line, it could get more complicated. It could take you longer time to get to the answer if you don't use the column method. The column method is fast, efficient, and could add big numbers together. So that's all I'm going to concentrate on. At the end of the day, you want to be able to add numbers together. The method you use is up to you. But I'm suggesting the column method, and we're going to stick to the column method in this series. if you're told to add, for instance, 28 plus 9 using the column method, of course, I'm sure many of you have already got the answer. You've done mental maths. You've counted from 28, 9, from 28, you go 9 forwards, like we did in the previous example. So 28, bring out 9 fingers, and then you count forward. Yeah, that's one way of doing addition. That's one way of doing addition. But let's use the column method to work this out. 28, 9, put a plus here, put a line here. Remember, in previous lessons, we've even already started using the column method, but the numbers had zeros in them. It was easy to do. We had zeros in some places and all of that. So we've already even actually started learning how to use the column method of addition. Now, with the column method of addition, it does not matter which number you put on top. I could put the 9 on top. I could do 9, 28. It does not matter which number you put on top. So all you do is you do 8 plus 9, that's 17. The 7 of the 17, you write it over here. The 1, you put it up here. Now, this is a digit of 1, but the value of this 1 from previous lessons, you should know it's actually 10. So this is not actually 1, this is the digit of 1, and its value is 10, because the 1 is in the place value of 10. In previous lessons, you should now know what we mean by value and place value. The value of this digit 1 is 10, and it's in the place value of 10. So let's start again. 8 plus 9 is 17. You write the 7 of the 17 here. The 7, the value of this 7 is 7 exactly. 7 in the 17 is in the units of one's place value, and that's why it's here. This part of our writing here, this line here, should have the numbers that are in the units of one's place value. 8 is in the units of one's place value. 9 is in the units of one's place value. But 8 plus 9 is 17. The 7, the 7 part of the 17 is in the ones or units place value. This digit of 1 is actually 10. So we have to move it. We have to move it to the tens place value. So strictly speaking, we should put a 0 here. You can now see that's 10. That's the 10. That's the 10. 10 plus 7 is 17. So that's the 10. But we don't like complicating matters with the column method. So no need to put the 0. Just put the 1 up here. Some people put the digit, just put the digit of 1 here. Remember, this is not actually 1, it's 10. So put the digit of 1 up here. Some people put it down here. But when I was in primary school, I wasn't taught to put it down there. It does not matter whether you put it up or down. But I prefer putting it up. It's better to put it up because it's close to the 2 here. Because you're not going to do 1 plus 2. And that's 3. So just to show you that it doesn't matter whether the 9 is up or down, we're going to add this together now with the 9 up. 9 plus 8, you get the same 17. You write the 7 of the 17 here. The digit of 1, you put it up here. You put it, you can make it smaller, put it on top of the 2. But remember, it's actually 10. That digit of 1 has a value of 10. And 1 plus 2, 3. You get the same answer. So I've used this simple example to show you the logic behind the column method. When you put this 1 up here, this digit of 1 up here is actually 10. It's moved to the tens place value. But you see, at times in mathematics, we don't want to dwell too much on why the method works. We can understand, for some methods like this one, we can understand, we can try and understand why the method works, like I've explained to you. But the main thing now is to master that method. Master the method. I've shown you why it works, but when you're now actually solving problems, keep aside why it works and just follow the method, stick to the method, stick to the rules of that method. So in further examples I'm going to be doing now, we're going to just stick to that method. So now let's do a two-digit number plus a two-digit number. So let's go with 54 plus 76. Remember, it does not matter which one you put on top or the one you put on top or below. And that's because, as we've said earlier on, addition is commutative. It's commutative. 54 plus 76 is exactly the same thing as 76 plus 54. Addition is commutative. Multiplication is commutative, as we'll see in future lessons. So when we are doing a column method of addition, it does not matter which number you put on top or below, because addition is commutative. So I tend to put the first number I see on top first. It doesn't matter. So I see 54 first. So I put 54 there. And then I put 76. Put my addition sign. Put a line under there. Then I go 4 plus 6, that's 10. The digit 0 of the 10, I put it over here. The digit 1 of the 10, I put it up here. I'm moving to the next place value. I've left this place value and I've moved to the next place value. I put the digit 1 here. Just to remind you, this digit 1 is actually 10. It has a value of 10. So 1 plus 5, 6 plus 7, 13. And 130 is the answer. If 76 was on top and 54 below, you will get the same answer, because 4 plus 6 will be the same as 6 plus 4. Digit 5 plus 7 will be the same as 7 plus 5. It does not matter. Addition is commutative. Now, with practice, you'll be able to do this addition quickly. You'll be able to do 5 plus 7. Within less than a second, you know it's 12. That's what practice is all about. In my primary school, we had booklets. In a lesson, we could practice 30 questions, 30 addition questions. So before you know what's happening, 5 plus 7, you already quickly know is 12. It comes instinctively. You will start off counting with your fingers, but if you do loads and loads of questions, bam, the answer just comes up straight away. 5 plus 7 is 12. 7 plus 7 is 14. 7 plus 8 is 15. 9 plus 4 is 13. You'll be able to quickly give an answer of a one-digit number plus one-digit number. The answer will just come quickly. Practice and practice makes perfect. So that's a two-digit number plus a two-digit number. Let's move on to a two-digit number plus a three-digit number. So if I'm given 396 plus 27, or let's say plus 87, we want to use the color method. You know, I said before that I prefer putting the first number on top and the second number below. Let me change that. I prefer putting the number with the largest number of digits on top. So basically, let me switch it around. 87 plus 396. So before I said I like putting the first number on top and the second number below. I'm going to rephrase that. I prefer putting the number with the largest digits on top, but it doesn't matter. If you put 87 on top, 396 below, you will get the same answer. If you put 396 on top, put 87 below, you will get the same answer because addition is commutative. 396 plus 87 is exactly the same as 87 plus 396. So let me just rewrite it exactly the way I wrote it before. 396 plus 87. It does not matter. So I put the 396 on top. It does not matter whether I put it on top or below, but I prefer to put it on top. Now I'm ready to start my column addition. Don't make the mistake of doing it like this, 396, and then you put the 87 here. This is something different that you're adding. Basically, 870 you're adding to 396. You must put it in the right place value. The 7 is in the units or ones. The 8 is in the tens place value. Let's do the addition now. You do 6 plus 7, that's 13. You write the 3 of the 13 here, the one on the right hand side, the one in the units or ones, put it in the correct column, units or ones, 3. This 1 here actually has a value of 10, so you have to put this digit of 1 in the tens place value, put it up here. Remember I said these days, teachers teach the students to put it below here. I wasn't taught that way. They said put it on top. It does not matter. Well, I prefer putting it on top because it's close. You can see it's close to the numbers I want to add it to. So I go 1 plus 9 is 10. 10 plus 8 is 18. That's 2 digits. When it's 2 digits, you have to do the same process again. So the 8 on the 18, you put it over here. The 1, you put it up there. Then you go 1 plus 3 is 4. And so the answer is 483. As I said, there are other methods of addition. Even though I said, yeah, we're going to stick to the column method, but this example is kind of getting me to show you another method, another way you can do it. 396 is 4 away from 400. So imagine if you did 400 plus 87, you get 487. But because 396 is 4 away from 400, you now take 4 away from your 487 to get the answer. That's one other way of doing it. So I repeat that other way again. I noticed that 396 is 4 away from 400. 396, 397, 398, 399, 400. 396 is 4 away from 400. So why don't I pretend that what I'm giving is 400 plus 87. 400 plus 87. Which you can do quickly in your head. If you like, you can use column method because you have zeros there. 0 plus 7 is 7. 0 plus 8 is 8. 4 plus nothing is 4. So 400 plus 87 is 487. But what I'm actually given is 396 plus 87. 396 is 4 less than 400. So why don't I make this 487, make it 4 less? 487, 4 less, go 4 below that, you get the answer 483. Just thought I should mention that other way of quickly getting an answer. But our main aim is to use the column method of addition. So let's now go on to a 3 digits plus a 3 digits. Same principle, no difference. We are just increasing the number of digits just to get more practice. It's the same principle. It's not harder. It just takes more time. It's exactly the same principle. So let's do 574 plus 888. Doesn't matter which one you put on top. Since they are both 3 digits, I don't mind putting the smaller number on top. Does it really matter which one you put on top? Then you do 4 plus 8, that's 12. Put the 2 of the 12 over here, put the 1 up here. And then you go 1 plus 7 is 8, 8 plus 8 is 16. Put the 6 of the 16 over here, put the 1 up here. And then you go 1 plus 5 is 6, 6 plus 8 is 14. And boom, you have your answer, 1,462. I want to say something here. If you notice, some people will not call this number 1,462. Maybe I should have mentioned this in previous lessons. They could say this number is 1,462. Some people do that. Maybe even probably the Americans do that, or even some British people do that, or some people do that. Technically, they are correct, but in an examination situation, I don't think that calling this number 1,462 will be accepted. But it is correct technically, because this is 1,462. The way I've taught it in the previous lessons, you must say 1,462. So don't let's fall into that trap. Because I don't think the exam boards accept that as an answer. Even though technically, if you think about it, it's another way of saying 1,462. Okay. So I was just double checking. That's what another thing in maths. Always double check. Always double check your work. There could be a small mistake there that could that if you didn't double check, you will lose marks. You won't lose all the marks, but you lose marks for that small mistake. Let's end it now with one example. Let's just end it with a 6-digit number plus a 6-digit number. In fact, no, let's do it this way. Let's add 3 numbers together. Because with the column method of addition, it does not matter how many numbers you add. So in fact, I changed my mind. Let's add 4, 5, or 6 numbers together and just end the lesson there. So what if you're given 283 plus 467 plus 18. Let's put over here 1. Okay, in fact, I want this number to be bigger. Let's say 35,283 plus 467 plus, let's say, 1,869 plus 589,326. Let's end the lesson adding all those 1, 2, 3, 4 numbers together. Some of them big numbers. The biggest of them are 589,326. Same principle. You write the numbers under each other, make sure each digit of the number is in the correct place value. And the order does not matter. Remember, addition is commutative. Whichever one you put on top, in the middle, at the bottom, or whatever, out of all these numbers does not matter. You will get the same answer regardless. I'm going to follow the order in which the numbers were given to me, just so that, because, yeah, the order doesn't matter. So why don't I just follow the order given to me? So, all right, 3, 5, 2, 8, 3, 4, 6, 7, 1, 8, 6, 9. I'm going to write this one from right to left, so I make sure every digit is in the right position. So I'm going to start with the 6. The 6 is the units or ones. The 2 is the tens place value. The 3 is in the hundreds place value. The 9 is in the thousands place value. The 8 is 10,000 place value, and then the 5 is over here. And you know what? If I like, I can put some zeros here, if I wanted to, but then it's not really necessary. I just need to double check that I've written everything correctly and in the right place. So I'm going to double check right now. That's my 35283. That's it right there. That's my 467. I'm not saying it in words. I could say 467, but I want to save myself time. So I'm just going to say 467 as I'm double checking. So 467 1869 589326. And let me make sure everything is in the correct line. Everything is properly lined up. You have to make sure everything is properly lined up. One mistake mucks up the whole answer. And if the total marks for this was 5 marks, you won't lose all the 5 marks if you make one mistake. Maybe you get 3 marks out of 5 or 4 marks out of 5. But why not get 5 out of the 5 by pausing and checking before you actually start your addition? In fact, double checking is good. If you have enough time in an exam or your classwork, double check. I'm going to double check again. So 35283, that's it right there. 467, that's it right there. 1869, that's it right there. 589326, that's it right there. Same line, same place value, same correct place value. I'm now fully satisfied. And now I can start my addition. 3 plus 7, straight away, I know it's 10. The more of these things you do, you just do the addition mentally in your head. 3 plus 7 is 10. 10 plus 9 is 19. 19 plus 6 is 25. So that's 25. That's 25 I've written over there. I hope it's showing. No, the 25 didn't show. So let's see if it's showing here. So 25. Let's do that again. 3 plus 7, 10 plus 9. 6. Yeah, the 25 shows. So 3 plus 7 is 10 plus 9. 19 plus 6, 25. The 5 of the 25, I write it over here. It's not showing. Let's move this up. So, yeah. Okay. So anyway, I'll push the answer up at some point. So the 5, I've written the 5 over here. The 2 of the 25, I've put it up here. And then I go 2 plus 8 is 10, plus 6, 16, plus 6, 22, plus 2, 24. I put the 4 of the 20, 24 over here. I put the 2 over here. 2 plus 2 is 4. Let me write this 2 properly. 2 plus 2 is 4, plus 4, 8, plus 8, 16, plus 3, 19. 9. I put the 9 over here, the 1, the digits of 1, I put it up there. 1 plus 5 is 6, plus 1, 7, plus 9, 16. The 6, I put it over here. The 1, I put it up here. 1 plus 3 is 4. 4 plus 8 is 12. The 2 of the 12, the digit 2, I put it here. The 1, I put it over here. 1 plus 5 is 6. So that's my answer right there. 62,600. 626,945. Now, you have to be meticulous in mathematics. Always double check your work. So I'm going to double check again. I like getting full marks. So I always like checking my work. So I'm going to check again. 3 plus 7, 10, 19, 25, carry 2, 10, 16, 22, 24, carry 2, 4, 8, 4, 8, 16, 19, carry 1, 6, 7, 9, 16, carry 1, 12. I'm satisfied that I got the answer right. So that's the answer right there again. So that basically ends our lesson on the column method of addition of positive integers. In future lessons, we'll be talking about adding decimal numbers and adding and subtracting negative integers. That's all in the future lessons. But in today's lesson, just to recap what we've done, we quickly reviewed how to write numbers in digits if it's given to us in words. We reviewed that from the previous lesson, and then we had a lengthy discussion about addition. We had a lengthy discussion about addition. We casted ourselves back to the primary school, back to when we were being introduced to mathematics, which started off with teaching us how to count, how to write numbers, one-digit numbers using words. So we casted our minds back to primary school, and then in primary school we moved on to addition. After learning how to count, they now told us how to count, but counting more than one thing. You're not counting, you're adding two things together, and then you count. Know what the total is. You're adding, finding the sum of two or more things. So we now talked about how from primary school we started with adding one-digit numbers to one-digit numbers, but when you move up a level, you now go on to adding two-digit numbers, and not using sticks anymore, or not using lines anymore, because it's going to take ages. And so we move on to learning the column method of addition. We've ended the lesson by adding 5 numbers together. 2 of them are very big numbers, but we came up with the answers quickly. So that ends our lesson on addition. In the next lesson, we'll be looking at subtracting positive integers. So I look forward to seeing you in the next lesson. Thank you.